Students, let's start with today's revision session. So as your CAT exam is going to happen, so have a quick revision of that. So here we'll have the concept revision first, so that if it is clear to you, you can have clear vision of all the numericals which could be asked. So the chapter is motion and time, as you all are familiar with. So what is motion? When the object changes its position with respect to time is called in motion. So here when the object changes its position with respect to time, we call it to be in motion. So here we can have the different concepts, like the first one, types of motion. So what are the different types of motion? The first one here, types of motion, transitory motion, already we did. So what is transitory motion? The motion which, the type of motion where the object moves in a straight line is called transitory motion. Transitory motion can be rectilinear or it can be curvilinear. So here, what is transitory motion? The motion in which all particles of the body move through the same distance in the same time is called transitory motion. So here all the particles are moving the same distance in same interval of time. So it's a transitory motion. It can be rectilinear motion. Rectilinear motion when it moves in a straight line. The motion of the ray. So your ray is the example of rectilinear motion where it is moving straight. Now the next one, another example, block of, like a block sliding down. You can see here the diagram is given. They kept a block which is sliding down. So this is also example of rectilinear motion. Now the curvilinear motion. The next category is curvilinear motion. When the motion of the object in curve, we call it as curvilinear motion. So here object is in curve movement. So it's a curvilinear motion. Now rotatory motion, when object is in rotation. There can be two kinds of rotation. So here it can be rotation around the axis or rotation around itself. So motion of the earth around the sun or motion of the blades of the fan. So these are the simple topics which we already have in 6th standard. So I feel like these are little least important. Now the most important topics, like we are having further in the session. So this is like the category which you can revise once and can go through for the definition or the concept based questions. Rotatory motion, then vibratory motion. What is vibratory motion or oscillatory motion? When the object is moving to and fro. When there is to and fro movement, we call it as vibratory motion or oscillatory motion. Pendulum is an example of that. The next one, periodic motion. When motion repeats itself in particular period of time, we call it as periodic motion. When there is repetition in particular period, we call it as periodic motion. So here, periodic and non-periodic. Periodic example, like motion of the needle of the clock. So here needle they repeat in equal interval, like after every hour. If it is hour hand, then minute hand, second hand. So there is regularity in that. So they are called periodic. When there is no periodic motion, then it is called non-periodic. Random motion, zigzag motion is called random motion. So as we are having a quick revision, I'm not going through in detail. So you can go through with all the definitions. So they are very simple only. Further, we are having much more difficult task here. So let's start out with the next topic. So in the next topic, once you can cover out all these questions. So here the first question is given. A bus is moving along a straight path and takes a sharp turn to right side suddenly. So here the bus is moving straight and it is turning towards the right side. So suddenly it turned. So when it will turn, the person will jerk towards that same direction. So answer will be, everyone will fall down towards right itself. Then which of the following as motion along a straight line? So motion along a straight line, motion of your hand while running. So it's not a straight line. So it's like to and fro motion. Motion of a horse pulling a cart. So all these questions are also very simple. I'm not going to repeat it. So you can have the revision of all this. So these are the simple concepts only. So next topic, like which we are having, let's start out with the sums. Numerical part is the most important one. So when they will ask you to write about speed and distance. So formulas are important, their units are important, which can be asked in multi-correct questions. So concentrate on the formulas very perfectly. Distance formula, distance is speed upon time. So distance is speed upon time. Next, distance SI unit, it's kilometer. And then when we talk about SI unit, it's meter. Kilometer as the other unit, they can ask like what are the other units. So there you need to concentrate about other units. What are the other units? So here the first topic is like time, already you know. And then this can be one of the MCQ. What is the speed of the light? It's 3 multiplied by 10 raised to 8 meter per second. Whenever we cover about speed, we need to write unit as meter per second. Next, types of speed. There is a difference between speed and velocity. They can ask like speed is a vector, speed is a scalar quantity, whereas the velocity is a vector quantity. Okay. So what are scalar and vector quantity? Scalar quantity, the quantities which has only magnitude but no direction, scalar quantity. Whereas the vector quantities, they have both magnitude and direction. So in that sense, velocity is vector quantity. Now here, mathematical representation of the speed. Speed is distance upon time. So already you all are familiar. Here in this session, they will be representing distance with small d and time with small t and speed with s. And SI unit of speed, it's meter. Okay, it's meter per second. And then it can be other, like they can ask about in multi-correct answers, what are the other units? Kilometer per hour or kilometer per minute. And then the changing also you must be clear with. Like if it is given kilometer per hour, to change it, already I explained, we need to multiply 5 upon 18. So that's once you keep in your mind. Next, these two instruments are important. Speedometer is an instrument which is used to measure speed, whereas the odometer to measure the distance covered. Speedometer and odometer, both are important. Like which instrument is, name the instrument used to measure speed, or the name the instrument which is used to measure distance cover. So this you can come across. Now two types of speeds are there. One is uniform speed, other is non-uniform speed. What is uniform speed? When object travels equal distance in equal interval of time, we call it as uniform speed. When object covers unequal distance in in equal interval of time, if the distance is unequal, we call it as non-uniform. The definitions are important for that. Then most important topic is average speed. Average speed and average velocity, they are very important. So how we are going to solve sums regarding average speed and average velocity? Let's move with that. Like average speed is total distance upon total time. So as the distance can be, distance can never be zero. When we come across the distance of the object can never be zero. So we can conclude like average speed can never be zero. That also they can ask in MCQ. Can average velocity be zero? So here average velocity can be zero, but average speed cannot be zero. Now let's start out with the sum part here. So here how we are going to solve out the numericals of this. Here average speed of a car covers distance of 100 kilometer in 5 hours. It's given it covers 100 kilometer in 5 hours. So how we are going to find out its average speed? So here vehicle covers, it's given it covers 100 kilometer. So distance is 100 kilometer in, if it is given 5 hours. So here first we will write distance and then time. Cancel out that. So average velocity, average speed will be 20 kilometer per hour. So the first example which is given here. Then the next one, car covers 20 kilometer in the first hour and covers 30 kilometer in the last 4 hours. Find the average speed. So when they will ask about average speed, we need to write about like what is the total distance. So here the first distance is 20 kilometer and distance 2 is 30 kilometer in first hour, that is 1 hour, and next last 4 hours. So distance 1, it's given 20 kilometer and distance 2 is 30 kilometer. Time 1, 1 hour, and time 2 is 4 hours. So as you know formula, average speed, total distance on total time. So thus it is 20 plus 30 whole divided by 1 plus 4. Thus 50 on 5. So final answer is 10. Very good. Because some of you answered it 10 prior to me. Very nice. 10 kilometer per hour. Will you write your name? Who is answering? Who has written 10? So we got 10 kilometer per hour. So this we completed. Okay, Sudhanshu, nice, very good. Now the next question. So this is about average speed. We need to write about total distance and total time. So in that way, you can calculate average speed. Now coming to average velocity topic. The next topic is average velocity. What is speed? Already we covered. Speedometer, instrument to measure speed. And then next here it is given a car travels the distance of 5 kilometer in 10 hours. What is the speed in kilometer per hour? So only we'll divide distance upon time. Distance is given 500. Time is 10. So 500 upon 10. So 0 will get cancelled. Answer is 50. Very good. Moksha, nice. The next one is a man can run a distance of 100 meter in 20 seconds. Find the speed of the man in meter per second. So again we'll divide both. 0, 0 will get cancelled. Now 2 5s are 10. So next answer is 5 meter per second. Clear? Third question, distance between two stations is given 5406. Train takes 3 hours to cover the distance. Calculate the speed of the train. Here they are asking to calculate in kilometer per hour and meter per second. If it is given kilometer, first we will be dividing both. To convert into meter per second, you need to multiply 5 upon 18. So first we will be dividing the distance. So the distance is whatever the distance they will give in general. Okay. So first let it be 540 kilometer. And then it's given 3 hours. So we'll divide them. 180 kilometer per hour we got. Now to convert it into meter per second, we need to multiply 5 upon 18. So 18 and 18 will get cancelled. Thus the answer is 50 meter per second. Okay, nice. 59 some of you wrote. Moksha, maybe by mistake you wrote 9. Okay, 50. Nice. Sudhanshu, now you are not answering. Okay, this is what we completed. Now the next one. Next is given physical quantity which is having both magnitude and direction. If you remember, is called vector quantity, which has both magnitude and direction is called vector quantity. Displacement is a vector quantity. Okay, why we call displacement as a vector quantity? Because displacement is the shortest distance between initial and final position. If suppose object started from A, it went to B, 10 meter, and it returned 2 meter. So displacement will be 10 minus 2. So this will be the displacement. Thus it is, okay Ritvik, nice. 10 minus 2. 8 meter will be displacement. Is it clear? When they will ask about the displacement, we need to subtract the values, given values, if it is returning back. And one more question, if you recall back, I explained you like in the circle, This is also an important topic I told you. Like when they will make 1/4 rotation, what is the displacement? Radius will be given. Okay, they'll give the radius, like radius is 4 meter. If radius is given 4 meter, for 1/4 of rotation, displacement will be diameter. How to calculate it? Small trick I told, whatever the radius will be given, that you need to put out with root. So this will be your displacement. Whereas to find the distance, we need to find out circumference fourth part. Circumference is 2 pi r. We'll be dividing it by 4. So it's pi r by 2. So once you revise all the formulas which I gave you regarding this, I gave 4 formulas. When it is covering 1/4, when it covers half, for half it is diameter, and again for 3/4, when it will cover 3/4, the same, 4 root 2 only. Okay. So these are the important questions which we can complete out here. Scalar and vector quantity, which I told you is important. Now the next one, physical quantity, which has both magnitude and magnitude but no direction, is called scalar quantity. Distance is a scalar quantity because direction is not there. SI unit of distance, it's meter per second. Already you all know. So all these type of questions will not be solving. So let's come across with sums again. 1 kilometer per hour is 5/18 meter per second. As we need to convert to meter per second, we need to multiply 5/18. If it is given in kilometer per hour, multiply with 5/18 to convert it into meter per second. Next, if it is given in meter per second, to convert into kilometer per hour, we need to reverse. So 18/5. So this bit can be important one. Okay, these two. If they will give kilometer per hour, multiply 5/18. If they start with meter per second, 18/5. Very good. Today Ritvik is not answering. Okay, now we completed this one. The next one, CGS unit of acceleration. Acceleration, it's a vector quantity because it has both direction and magnitude. And next, CGS unit, many times you get confused. So when they ask about SI unit, it's meter per second square. When it is CGS unit, centimeter. Okay, there are 3 kinds of units. So one can be CGS one. Mostly we use CGS and SI unit. SI unit is MKS unit, where for the length we use meter, for mass we use kilogram, and then for time second. In CGS system, for length centimeter, gram for the mass, and second. So here you are finding unit of acceleration. So unit of acceleration is unit of acceleration is meter per second square. This is SI unit. When they are asking about CGS unit, we need to write CGS unit of length. So it's centimeter per second square. Don't get confused what they are asking. You need to decide answer as per that. If it is CGS unit, centimeter per second square. If it is SI unit, meter per second square. Okay, now the next topic. The rate of continuous increase in velocity of the body. When the velocity is increasing, we call it as acceleration. So these are also simple topics you can cover by your own. What are the other watches which can be used? So like that they can make simple questions out of that. Now unit of time. Unit of time, already you all are clear with. Okay, Moksha, what acceleration you want to, okay, that answer you gave. Okay. Next, graphical representation. If you remember graph, I told you like if it is distance time graph, y-axis will be representing distance, x-axis will be representing time. From distance time graph, slope of the graph, it's OY upon OX. That is, this line is called slope. We need to find the distance on y-axis and distance on the x-axis. If we divide, then we get slope. and slope of the distance time graph, it gives distance upon time speed. When they will ask about what is the slope of the graph of distance time, here you need to write speed. It gives speed. How we are finding slope? So if you remember, distance we calculated on y-axis and time we calculated on x-axis. If we divide both, we can find speed for the particular we can find out the speed related to particular value. If suppose they will ask what is the speed at the interval of 10. So here the time is given in seconds. What is the speed at 10 second? What is the speed at 10 second? Okay, Virat. If they will ask speed at 10 second, if you remember I told we need to make one vertical line and one horizontal line. First we'll be taking the slope of y, that is horizontal one. Horizontal is representing 100. Vertical is representing 10. So it's 100 upon 10. Zeros will get cancelled. Answer is 10. So whenever they will ask about like graph based question, obviously one question will be there which could be of integer type. So here whatever the value they will be giving, like here 100 is there, then 200, 300, and here if suppose it is 10, 20, 30, if they'll ask speed at 10 seconds. So first we need to make the vertical line on the 10, and from the same point we'll make one horizontal line. So here 100 upon 10. So answer will be 10 meter per second. So like that, whatever time they will be asking, you need to just divide them. So these kind of questions are very easy, very easily you can do it. Now distance time graph of the non-uniforms. Here they can ask one more bit part, like what is how the graph looks for the uniform speed. Graph is a straight line. If you remember, graph is a straight line passing through the horizon, I told. Okay, it will start from horizon and it will be a straight line for uniform. When it is non-uniform, it's a zigzag line. Non-uniform means speed is increasing, decreasing, so it will be a zigzag line. Okay, like in MCQ they can ask what is the graph of uniform velocity. You need to write straight line, or if they will give there is a graph, distance time graph is straight line, what does it represents? Answer will be uniform speed. Now next question, device, already we did all this. So this let's start out with the summary part now. Now here like this question can be, which of the following is equivalent to 1 hour? 1 hour. So here 3600 million seconds is given, 3600 milliseconds is given. So how we are going to convert into milliseconds? So first you need to convert it into second. 1 hour is equal to 3600. To convert into milli, you need to multiply 1000. Option number C. Okay, Virat, very good. Already 3600 is, okay, Sudhanshu gave answer. 3600 is there. We are multiplying with 1000. So 3 more zeros got increased. When they will ask about milli, milli means 1000 to be multiplied. Whatever the answer is there, will multiply 1000. Option A is wrong, Moksha. Okay, here it is given milliseconds. No? 1 hour is milliseconds, so this answer will come. Option number C. Now the next one, which of the following is not the unit of time? So here, not the unit of time. Tropical year, minute. So here second, light year, minute. Tropical year is not the unit. So this type of questions you'll be doing. So now we'll be covering only numerical part. So this is all I'm not explaining. Now the next important topic is laws of motion. So here in laws of motion, what we come across? There are 3 laws. First law, what does the Newton's first law says? Newton's first law states that if the object is at rest, it will be in rest. If it is in motion, it will be in motion. Okay, from there we are getting the definition of inertia. What is inertia? Inertia is a property which makes the object to continue its state. If it is in rest, it will make it to be in rest. If it is in motion, it will make it to be in motion. There are 3 kinds of inertia: inertia of rest, inertia of motion, and inertia of direction. So 3 kinds of inertias are there. Okay. And next, the rest is making the object to be in rest, motion is making the object to be in motion, and direction, it helps to change the direction of the object. Next, from first law, we are getting the definition of inertia. Newton's second law is giving the definition of force. So now, how we will get the force? Force is proportional to change in momentum. Momentum is given by small p with respect to time. As it is change in momentum, so it's mv minus mu. What is momentum? Momentum is product of mass and velocity. So here unit of momentum will be mass unit kg. For velocity it is meter per second. So this can be again one more bit. What is the unit of momentum? Force is change in momentum. So it's mv minus mu with respect to time. Thus, F is equal to, M can be taken common, V minus U by T. They can ask two kind of questions over here. If they will give initial velocity and final velocity, use this formula. As V is final and U is initial one. Okay, when they will give initial and final velocity, you are going to use this formula. If they will give acceleration, V minus U by T is A. So we can write the formula MA. F is equal to MA. So depending on the question, you will be choosing the formula which to be done. Now force formula can be M V minus U by T, or it can be MA. If acceleration is given, MA. If initial and final velocity is given, use M V minus U by T. Is it clear? Shall I move further? Okay, next unit. Unit of force is Newton, which is given by capital N, or spelling with small. Okay, next one. Next topic is, like, after this, what is the relation between Newton and dyne? CGS unit is dyne, whereas SI unit is Newton. If you remember, I explained you, like 1 Newton is equal to 10 raised to 5 dyne. This also can be one of the bit part. So remember that. What is the relation between Newton and dyne? So 1 Newton is equal to 10 raised to 5 dynes. Dyne is the CGS unit of force. Now, next topic, this is the second law. First law we covered, second law. From second law, we are getting the definition of force. From first law, we are getting definition of inertia. And third law, to every action, there is equal and opposite reaction. Action and reactions are equal and opposite to each other. That is the third law. Third law only example based. You need not to worry about that. And third law gives us the conservation of momentum. So here, all this topic, once read it. Second law, derivations are not needed. Directly for the sums, you need to read. Application of second law, second law, kicking a ball, pushing a cart, two people walking together. So all these are the applications. Once you go through with the application and this relation, they can ask 1 kilowatt. So here WT is representing weight. So it's a 9 dyne. So once you recall this part also, okay, go through with this. This can be asked in bit part. Now the next question. So here it's given, if there is a block of 2 kg and force of 20 Newton is acting on positive x-axis, force of 30 Newton is acting on negative x-axis, then what would be the acceleration? From one direction there is 30 Newton, from other direction there is 20 Newton. So there is a difference in the force, 30, 20 minus 10. So the net force is minus 10. Mass is given 2 kg. They are asking about acceleration. Force formula MA. So here there is a block, there is 30 Newton force and another direction 20 Newton force. So we'll be subtracting them. Answer is minus 10 Newton. Okay. So here we need to find acceleration. So it's force upon mass. Force is 10, mass is 2. So 5. Acceleration is 5 meter per second square. On force, mostly they will give this kind of questions which are very simple and straightforward questions. Now the next one, force, how much force is required when 1000 kg of car is at 4 meter per second square acceleration? Mass is given 1000 kg and acceleration is given 4 meter per second square. We need to find what is force. Force is MA. Thus it is 1000 multiplied by 4. 4000. Unit will be Newton. Is it clear? Okay, next question. Okay, the next one is it is required. This fourth question I'm explaining now once. So these are all like what we did, the same kind of questions. It is required to increase the speed of a scooter weighing 80 kg from 5 meter to 25 meter in 2 seconds. How much force is needed? Here, two different velocities are given. One is 5 meter, other is 25 meter. Time is given 2 seconds. We need to find force. So we'll apply another formula. F is mv minus u by t. So here mass is 80 kg, v is 25, u is given 5 in time interval of 2. So 2 40s are 80, 40 multiplied by 20. The answer is 800 Newton. Okay, only two kinds of questions will be there here related to force. If initial and final velocity is given, you are going to apply this formula. Otherwise, the previous one, MA. So now this part got clear. Still few more questions are there. So rest I'll cover in school tomorrow. So that's average velocity and average speed type of questions are there. Rest is done. This graph is there a little bit. Okay, now I need to take 10th standard also. So I'll wind up this and I'll start 10th standard. If we'll get time, so, tomorrow in school we'll complete out rest of the things. Only two topics are remaining now, average speed and average velocity, and little bit related to graph. Already we did, so the chapter will get over. So once all of you go through with everything, like whatever the solutions are given to you, still if difficulties are there, ask me tomorrow. Most probably everything you will get it, so no need to worry at all. Okay, thank you those who attended. Have your practice.